We're just about to add this Ethernet segment to our EIGRP deployment. Just a couple of quick notes here. I do notice that I have loopback 0 written on each one of the loopbacks in this drawing. And of course, there are loopbacks 1, 2, and 3 in our lab, but using the same addressing on routers 1, 2, and 3 respectively. Also, you might want to draw this one out because we're going to be looking at different paths for one router to get to a certain destination. And I think it will go better on you if you have a drawing of it in front of you that you can draw arrows on. So let's go ahead and get that network added. And we'll start over on router 3 since we're already there. And what is that fourth octet? You might have seen it on the board. What is the fourth octet if we're looking at a /27 network, a /27 network mask? That means we're going to have 5 bits in our wildcard mask, and that's going to be 31. So let's go over to 2. And there we go. So let's see, we get a neighbor change message very quickly. We have a new adjacency via fast Ethernet 0/0. Fast E is all you're missing there. And with our neighbor 23.3. But we're going to look here and verify just in case. And you can see we've had one adjacency, the one with router 1 now. It's been up for almost 17 minutes. And the one to router 3 through the Ethernet has been up for about 15 seconds. So let's go back to our drawing here because this gives router 1 a couple of options. And actually it has a pair of options for every network it knows about via EIGRP. And that would be the loopback on router 2, the loopback on router 3, and the Ethernet segment connecting routers 2 and 3. And Dual has already made its mind up. The EIGRP routing algorithm has already decided the best path, but let's talk about the decisions it had to make. First, it knows, EIGRP knows, that router 1 can reach the Ethernet segment in 2 different fashions. It can do so by going through the cloud to router 2, and then you're right there at fast Ethernet 0/0. Router 1 can also send packets to router 3 through the cloud, and you're right there at fast Ethernet 0/0. It's a connected network in both cases. Okay, now a little more complicated path as far as the loopbacks go. Router 1 can reach router 2's loopback by going through the cloud directly to router 2, and you're there. It can also go to router 3 through the cloud, then through the Ethernet, and then you're at router 2. That one seems a little longer than the first one, right? Just eyeballing it. And we know that we can't always just eyeball something and tell how fast a path is going to be, but it sounds like the better path would be just to go straight to R2. Now, as far as router 3's loopback goes, router 1 has 2 paths to that one as well. It could go straight to router 3 through the cloud, and it probably will, but it could also go to router 2 through the cloud, and then router 2 forwards the packets over the Ethernet segment, and then therefore to router 3. So it looks like we have 2 valid loop-free paths for each one of those 3 segments, router 2's loopback, router 3's loopback, and the Ethernet segment connecting those 2 routers from router 1's point of view. So now that we've talked about it, let's see what EIGRP decided, and we'll go up to router 1 and take a look. And kind of a mixed bag here, because you can see that we only have one entry for router 2's loopback, and as we would expect, it's using router 2's serial interface as the next hop IP address. As far as router 3's loopback is concerned, router 1 is going to send packets directly to router 3. You can see the next hop IP address there is 172.12.123.3, which is router 3's serial interface. However, when it comes to that Ethernet segment, it seems to be splitting the load somehow because we've got 2 addresses listed next to the D for Dual, which stands for EIGRP, of course. And one of them is using router 2's serial interface as the next hop, and the other entry is using router 3's serial interface as the next hop. So why do we have 2 entries for the Ethernet segment from router 1's point of view, but only 1 for router 2's loopback and router 3's loopback? Well, the answer is contained in a default behavior of EIGRP called equal cost load balancing. because the metric for those two paths to 172.12.23.0/27, they're exactly the same. Now, again, we're not exactly talking RIP's little metric of hippity hops here. And if you've never seen RIP, you're okay because it's not going to be on this exam. But RIP the metric is hops, which is not an incredibly scientific way of coming up with the best path. So EIGRP, as you can see, is a little more complex. We have a 7-digit metric for just these two little lab paths, so you can imagine how big they end up getting in real-world networking. And they're exactly the same. That's not going to happen very often in EIGRP, but it is happening here, and EIGRP has decided, okay, we're going to perform equal cost load balancing over these two paths. Now, what about those loop-free paths to router 2 and router 3's loop back from router 1? There was a longer way to get to each one of those from router 1's point of view. And where these routes that we see in the routing table, they are the successor routes. We talked earlier about a valid loop-free route with a metric not quite as good as the successor as being a feasible successor. And plenty of talk coming up about that to come too. I've got some more labs. But right now, let's take a look at our topology table, because here you're going to find your successor and your feasible successors. You're not just going to find the successor routes here. And you can see for the entry for that shared Ethernet segment, the one where we're performing equal cost load balancing, you see two successors. And yeah, you can actually have more than one successor, and that means that you are actually using equal cost load balancing if you've left all the defaults alone. And you can see the two next hops are exactly what we think they would be. Now, as far as the paths to router 2's loopback are concerned, we see one successor, but we see two paths. So which is which? Well, this FD stands for feasible distance, and we're going to be talking about feasible distance and advertised distance quite a bit still coming up in this section. But I just want you to notice right now that just look at this value. FD is 229.7856. Just look at that value when you want to identify your successor, and the one that has that exact same value here first, that is going to be your successor route. So the successor for the path to router 2's loopback has a metric of 229.7856. Well, the other path, that's just a little bit slower. 2300416. That's not much higher, but still they are not exactly equal. So right now, router 1 is just saying, okay, if I need to send anything to the 2220 network, I'm going to send it using 123.2 as the next hop, and 123.3, that path can step in if it is needed. Now let's look at the entry to router 3's loopback, and it's just kind of a mirror image. We have one successor again, and as we would expect, that successor is using the next hop IP address of 123.3. Here's the matching feasible distances. But again, that other path to using 123.2 as the next hop IP address, that metric is just a little bit higher. So we might want to bring that path in to our load balancing, but we're going to have to do that manually because, not being a smart aleck here, but if we have equal cost load balancing when the values are exactly the same, what do we have when they're not exactly the same? We have unequal cost load balancing. And that's what we're going to configure here very shortly with the variance command. As a matter of fact, I'll stop this video, and in the very next vid, we will take over with the variance command. I'll see you there.